Very good morning to everyone. As part of our C# learning journey, we are going to discuss about our next topic. Our next topic is nothing but operator. First of all, we all have to know about what is operator. The operator is the one which take one or more operands as input and return some value as a result. So it used to process inputs and will come up with a result, right? So the operation can be an addition, a multiplication, a division, a modulo operations, you name it. There are many operations, mathematical operation that we can perform on operands. So to perform those, in C#, we have a list of operators, as we have operators in other programming language. Every programming language has these operators. C# is not an exception from them. So it also has its own operators, right? So they divide the total operators that we have in C# into different groups. So they are called as, some of them are called as arithmetic operators, those who perform an arithmetic calculations. And then some of them are used for assignment and they call them as an assignment operator. Some of them are used to compare two entities, then those are called as comparison operator. Some of them are used to find out whether certain thing is true or not. Based on that, they will perform certain operations. So those are called as logical operators, right? Then we want to do some of the operations on the bits of operand, like right shifting, left shifting, and then ANDing bitwise and bitwise OR. To do these sort of operations, the operator used are called as binary operators, right? There are certain operators, those are used for type conversions, like as there are many, those are called as type conversion operator, right? So these are the different groups that we have in operators. So here is an example for them, right? So here we have a list of operators and their respective group. When it comes to arithmetic, we have a minus, plus, star, division, modulo, plus, plus, and minus, minus. Whenever we want to subtract two entities, we can go for a minus operator. And when we want to add them together, we can go for plus operator. When there is a need for multiplication, we can go for a star operator. Division is to find out the quotient. So when you want to find a quotient of division, then you can go for division operator. We do have another operator called modulo. This will return the remainder of your division. So instead of returning quotient, it will return the remainder that is needed to find out many logical things when we do programming. For that, they use this modulo operator. Then we have plus plus and minus minus. When you want to increment your operand one step, you can go for plus plus. When you want to decrement your operand one step, you can go for minus minus. These are the different arithmetic operators that we have. Then we have a logical. When you want to do certain actions based on two different conditions to be when the two different conditions are true, right? If those two are true, then you want to perform certain things. In that time, to bridge a a connection between, or to bridge those two conditions together, we go for this logical AND operator, right? When you want to check any one of the condition is true and want to execute the operation, then you can go for OR operator. That means a pipe operator. When you want to say like something is not equal to, if this is not equal to that, then you can use this exclamation operator. We have two conditions, they are opposite to each other. That means one is true, another is false. In that time, you want to do certain things, you can, in that case, you can go for XOR operator, right? We do have an binary operators like to perform logical AND, logical OR, sorry, bitwise AND, bitwise OR, bitwise XOR, bitwise complement. That means making all bits from 1 to 0 or 0 to 1. So when you do a complement, you can, when you want to do a complement, go for tilde operator. When there is a need for left shifting or right shifting, you can use these left shift and right shift operator. See, when you right shift certain thing by one bit, when you do a 1 bit right shift, which is equivalent to dividing that operand by 2. When you left shift something 1 bit, which is equivalent to multiplying that operand by 2. So this is very frequently used for various reasons in programming. That's why we have this left shift and right shift operators here. Then we have comparison operator. When we want to compare two entities, whether they are equal, then you can go for equal to operator. To check whether they are not equal, you can go for not equal to. So to check something is greater than another thing, you can use a greater than operator. Less than another thing, we can use another operand. We can go for less than operator. We do have a greater than or equal to and less than or equal to. These are comparison operator. When it comes to assignment, the very popular operator that we used is an equal. Along with that, we do have an compound assignment, which means like sum is equal to sum plus uh, like the sum plus x, right? Maybe it can be 1 or it can be n, whatever it is. When you want to do these sort of the compound assignment, the entity is equivalent to entity plus or entity minus, like that. You can go for this uh, compound assignment operators that we have: plus equivalent to, minus equivalent to, multiplication, star equivalent to, division equivalent to, modulo equivalent to, and equivalent to, or equivalent to, XOR equivalent to, left shift equivalent to, right shift equivalent to. Like that, we have a series of operators for these for assignment. You can use them for doing assignment right now. Then we have a concatenation operator. When you want to concatenate two different strings together, you can use a plus sign in between them. If they are string, they are connected, they are concatenated, and the end result would be like concatenated string. If they are two numbers, then the result will be addition of those two. So it depends on the operand data type. They will perform, they will choose right operation to be performed, right? Then we have a type conversion operator like as, and then with typecasting operator bracket. Within that, we used to have a data type, and then there is an ease operator, type of operator, size of operator. We will discuss them in detail. As of now, you just know what they are, and then what their name is like. So if you know that, that's enough. Then we have another operators like a dot, a new, and brackets, square brackets, ternary operator, and then a double question mark operator. So these are the different operators that we have in C#, right? So then we have something called as console IO. After operators, we have a console IO. The console IO functions are just like an input output functions. So they will receive inputs through a basic input device and will output the result in basic outputs device. Usually basic input device will be your keyboard and output device will be your monitor, right? That used to be like that. So here are a list of functions. Those are used for console IO, like console.out.writeLine, console.writeLine, console.write. So these console.out.writeLine and console.writeLine will print certain things in the basic output device. Also will include a new line character, so that every time when you print something, you will have them in a separate line. So that's how it is. So then we have a console, right? This won't include any new line, so that you will get your that means it won't have a new line. That's it. That's it. So when you print a string, it will print consequently one after another. It is in that way, right? Then we have an index component in console IO. So even when you are printing in a screen, so you can frame a formatted string using something called as an index component. What is index component? Which is nothing but, for example, I want to say the vehicle speed of the car is, and certain X vehicle speed, which is variable, and then engine RPM of the car is Y. Like these two are variables, right? When I these two, when I print them, it should be displayed in such a way that vehicle speed of vehicle speed of the car is, for example, if it is a 60, it should display 60. Engine RPM of the car is, if it is 3,500, it should display 3,500. So it should be in that way. So when you encounter such a case, so you can have a index, because we have two variables to print. So you can say your first index in the first occurrence of the variable and the second index in the second occurrence of the variable, so that your formatted string will be the vehicle speed of the car is within, we have a zero within a curly brace, and then the engine RPM of the car is, we have a 1 in the curly brace. So this will make them as a indexed one. So appropriate operand or appropriate entity will be printed in the respective place. It is purely based on their index. So if you, while you are supplying these operand to the function console dot write line, so you have to supply them in a sequential way. I mean the sequence in which you want to appear, you want to see the text in the screen, no? According to that, you have to supply those operand to that functions. Right. So it is in that way. So this is, that is what called as index component. So we'll discuss them in detail when we discuss console output and input. Then we have an alignment component. So you can add an extra spaces in between your operand and while they are printing, while we are printing them, and then right, we can even do that, then that is called as alignment component. So you can do a right shift and right alignment and left alignment. Right now, when you require a left side alignment, you can use a uh, negative, what do you say, negative number for how many characters you have to see them in the left, right? So in that way you can specify. So when you use a positive number, they will use a right alignment, right? According to that, they will do that alignment. We'll see them in detail in upcoming sessions, right? We have something called as formatted string component. That means that you can use certain formatted format strings to format your outputs. For example, when you want to print something, when you want to print a number which includes a currency symbol, then you can go for C. When you want to print something in decimal, you can use D. When you want to print something in X, you can go for X. That means X value. So when you want to print something as in percentage, you can use P. These are the format string components. We have a custom number format. So when you want to do a custom format for your numbers, number of digits that you have, and then after decimal point, how many digits you need to have. So you can define them by your own using these custom number formats, zero, hash, dot, and then we have a percentage symbol. We do have a custom date format like single D, double D, capital M, small m, and then two Y's and four Y's, small h and capital H, and small m and capital single m and double m, and then single s and double s. So these are like when you use a capital, which means that you are using a 24 hours format. When you use small lowercase letters, which means that you are using it is 12-hour format, right? No, so it's in that way. These are the function when you want to print certain thing, you can go for them. We have another set of functions that is used for reading. So like console.readline, this function will read input from the user using console, basic console input device, right? Probably our keyboard, mouse, or something like that. When it read, right? So it used to be in the format of string. So it is your responsibility to convert them to appropriate type, right? Appropriate data type. For that, we have parse functions for in dot parse, double dot parse, right? Then these are the different parse function that we can use for data type casting or typecasting right now. So there are conditional parsing as well, that uses the try parse right now. So if there is a invalid value is supplied, then you can print the str that you want to print. If it is in a proper input, the user has given a proper input, then that will become an output, right? Output of a particular data type. So then we have a console.read key. This function will read a single key from the user, and then that is used for making decisions, right? So that's how it is. Read line will include a new line, and then read, it's just like in reading input from the console. That's all. Right. These are the different console IO functions that we have in C Sharp. So now we have a basic understanding about the operators and then console IO functions. Let us do some sort of programs to understand them. Right now, we have a problem statement here to be to understand what we learn, to register them in our brain. We have these problem statement as we used to have in every courses of ours, right? Let us do these programs and learn, and learn operator and console IOs, right? So here is a program. The program says like create a program which increase the vehicle speed by 2 kilometers per hour when the radar does not detect the forward vehicle, right now. So this is a problem that is related to ACC vehicle, right? So when you have an ACC vehicle in front of it, you also have a forward vehicle that used to be. So if when the radar of ACC vehicle detects a forward vehicle, in that time it will adopt the speed according to the forward vehicle. If there is no vehicle in front of it, it will accelerate itself to the set speed right now. So for that, we have to write an algorithm. So the problem statement states that create a program which increase the vehicle's speed by 2 kilometers per hour when the radar does not detect the forward vehicle for more than 5 seconds, right? So when these conditions are met, then we have to and vehicle speed is less than target. Also, our vehicle speed should be less than the set speed. If that is the case, the acceleration will happen. So let us write program for that now. Plus plus. So we can call this as ECC acceleration. Vehicle acceleration dot CS. Right here, using system class vehicle underscore SCC static void main. Yes. So now it is time to. So the program says that create a program which increase the vehicle speed. So we need an entity called vehicle speed. Let me create that. So usually it used to be in with the data type byte vehicle speed equal to, let us assign that it's 70. Then second thing is when the radar does not detect for vehicle. So we need another status called as forward vehicle status. So that is by default, as it is, there is no forward vehicle, then we can say false. Seconds. So that means the timing parameters involved. So we can call that as short or yeah, short free time is equal to some 6 seconds, right? Then we have less than target speed. The vehicle speed should be less than target speed. That means we require another entity called target speed. Right now. So let us write the logic now. If so, what they are saying, create a program which increases the vehicle speed by 2 when, if, which means if radar does not detect the forward vehicle. So we have to check forward vehicle status equal to false. If it is false, then we have to combine in another condition because we have more than one or more than 5 seconds. That means free time is greater than 5. Vehicle speed is less than target speed. So vehicle speed is less than target speed. Right. So probably in our design, all these conditions are true. Like for vehicle state is equal to false, free time is greater than 5 seconds, and the vehicle speed is less than target speed. When these conditions are true, what we expect, the outcome expected is we have to increase the vehicle speed by 2 km per hour. Vehicle speed is equal to, we can say vehicle speed plus 2. This can be done. We can also do it in another way, which is like instead of duplicating this vehicle speed 2 times, we can say plus equivalent to. Both have same meaning, right? Vehicle speed is equal to vehicle speed plus 2, right? At the end, we want to print the result. Console dot write line right? We are going to do an printing using indexing component. Current vehicle speed is, right? So you have to give your index of our entity. Index is the first that we are going to print is vehicle speed right now. So just do that. Right? That's all. Let us run this program now. So to compile it, CSC vehicle underscore acc.cs. Okay, it says namespace system. Okay, maybe I didn't use a proper case here. It does not exist in current and vehicle speed does not. Maybe I think the same mistake I'm doing in multiple places. Vehicle speed, forward vehicle status. I think let us follow the same pattern, camel case. So that would be more, follow the same thing, right? So now it will become forward vehicle status free time vehicle speed target speed done vehicle speed. That's all we have. Right? I believe. Forward vehicle status not forward vehicle status. Vehicle status. Right? Now it is compiled. We have a exe here. So we have a exe for vehicle acceleration, but we need an exception from firewall. So open McAfee because I haven't. So add file, vehicle acceleration, and then I just close this. So I'm going to run it now. So they are printing my current vehicle speed as 62. Is that correct? So my previous vehicle speed was 60, and when these conditions are true, I increase that by 2. That's all. So it's working. Okay, team. So this is how we have to write programs, which is based on conditions. To combine them, we use a logical AND operator. Right. So when you want to do a compound assignment, we have to use this plus equivalent to. So that is explained here. When we want to use an indexing component for printing, right now. So we have to provide the index of the operand that we want to print inside a curly brace, and then you write it. Right. This is the uh, program which make the decision based on more than one condition. Okay. Okay, team. That's all for today. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.